This little spinner has on it what, in my opinion, is the most important picture in the history of science. And while I work up to telling you about it, I'm gonna spin it and see how long it can go. Because in order to tell you about this image, I have to ask you a question about atoms. And that question is, do you know that atoms exist? Like, for sure? And more than that, do we know that atoms exist? Is that a thing that humanity, 100% definitely has nailed down? Like, if you pressed me, I couldn't really tell you what atoms are. Certainly, they are some combination of protons, electrons, and sometimes neutrons. Certainly, there's a nucleus and an electron cloud. Also, by definition, they're neutral. If there's more electrons than protons or more protons than electrons, then that's an ion. And certainly when you do chemistry, it only ever happens in whole number increments. There's definitely an atom-like thing going on there. And this was actually the first big hint that atoms might really be a real thing. When early chemists did early chemistry, they kept finding these nice big whole numbers. When you break water apart, you don't just get hydrogen and oxygen, which is a very weird outcome on its own. You get exactly 2 parts hydrogen for every 1 part oxygen. I mean, as exactly as their methods and instruments would allow. But that is not enough on its own to say that an atom is a real physical thing. Maybe there's just some other force pushing everything toward these whole number ratios. A century after John Dalton and Joseph Proust noticed these ratios, scientists were still arguing about whether atoms were a real physical thing or just a useful mathematical tool. It's still going. But if there's one thing you know about Albert Einstein, it's the whole E=mc² thing. But if there's 2 things you know, it's probably the photoelectric effect. But if there's 3 things you know, it's that he also kind of proved that physical atoms actually exist. This is a big deal. The fact that this is not his most famous discovery is honestly pretty messed up. Perhaps he should have, done a little less. Leave something for the rest of us. In 1905, Einstein used math to describe a very weird effect called Brownian motion, where little flecks of stuff on the top of water would jitter, seemingly at random. Einstein's math proved very elegantly that this would only happen if the water itself were made of tiny particles bumping into pollen grains. Oh, it stopped. It stopped. Turns out I can go longer. The fact that Einstein showed that if atoms were real, tiny particles suspended in water should jitter in a very specific way that was indeed the way that they jitter here in the real physical world convinced a lot of people. It was kinda seeing atoms with our own eyes, but it was not actually seeing atoms. And even though Einstein's 1905 Brownian motion paper is often cited as the moment that we knew for sure that there really were atoms, many scientists continued to argue that atoms weren't a real thing and they were more of an idea for quite a long time. After all, if atoms were real, why couldn't anyone see one? Now you might be thinking, is this what I think is the most important image in the history of science? Is this the first picture of atoms? No, it's not. But it kinda is. We're gonna get to it. Atoms, it turns out, are incredibly small, about 1/10,000,000th of a meter across, which is pretty strange. That's just very small. Also, it turns out quite a lot smaller than the wavelengths of visible light. So atoms, actually, are literally impossible to see with the light we use to see things. So surely, seeing would not be the thing that would put the final nail in the coffin of the atoms don't physically exist theory. But right around this time, something else very interesting had been discovered. A new kind of light. God, this must have been very exciting and weird at the time. That new kind of light was the X-ray. And importantly, no one in the early 20th century knew what the heck an X-ray was. Some scientists thought that they were particles, others thought that they were waves like light, just with way shorter wavelengths. And if that were true, then perhaps those waves might be small enough to interact with atoms. And this was the very clever insight of not Einstein, but the German physicist Max von Laue. He thought that perhaps X-rays could interact with atoms, and he had the perfect tool for testing this: crystals. The atoms of crystals are arranged in extremely regular repeating patterns. Salt, quartz, diamond, they all have atoms arranged in orderly grids. And if X-rays were really waves and atoms were really physical objects arranged in these orderly patterns, then sending X-rays through a crystal should do something very specific and very cool. Each atom would scatter the X-rays a little bit, and those scattered waves would interfere with one another, reinforcing in some directions, canceling out in others. If you placed a photographic plate behind the crystal and shot an X-ray through it, you should see a specific and symmetrical pattern when you develop the plate. If that happened, X-rays would definitely be waves, and atoms would definitely be things. And in 1912, while the atom debate continued to fester, two of von Lau's colleagues did exactly this, firing X-rays through a crystal of copper sulfate and onto photographic plates. And when they went and developed the film, this must have been very exciting. They saw this, a constellation of spots arranged in perfect symmetry. This photograph revealed two deep truths about the universe at the same time. X-rays were not mysterious particles, they were a new kind of light, electromagnetic radiation with much smaller wavelengths. And second, crystals were not smooth continuous solids the way they appear to be to us. They were built from extremely tiny objects arranged in precise repeating structures. Now, this was not a photograph of atoms. We would have to wait decades for that, if you can call what we do now when we image atoms a photograph. This was instead the pattern atoms imprint on light as it passes through them, which, let's be honest, is cooler. It is so cool that I would like to make you a deal. Are you ready? So some of you watching this video, you would like to celebrate von Lau's work and humanity's labor of never being satisfied and always striving to figure out more, to the point where we now teach seemingly unknowable truths to every elementary school student. This is remarkable work. This is human work. It is the work of science. And here at SciShow, we love to tell you about that work. We love what we do. We are also part of Complexly, which is a 501c3 nonprofit full of people working their butts off to make high-quality, accurate videos free for everyone. Now, many of you support Complexly or SciShow on Patreon, which is amazing, but we know that some people like to donate just once instead of a monthly payment. So for the third year in a row, we are selling a $60 postcard, this time with a bunch of very cool SciShow stickers on it. Now, $60 is too much for a postcard, but it's pretty good for 4 SciShow videos a week all year round. $5 a month for 16 brand new videos? I don't mind it. Send it to a friend. The whole idea is that a very small number of people support us with money so that the content can be free for everyone. Some of you have been asking for something cooler, something shiny, something collectible to represent your love of SciShow, to show all of those Crash Course fans that SciShow has super fans too. And that's why I asked the team to cook up this spinner. On one side, it's got this X-ray crystallography image. On the other side, our SciShow logo. You can buy this right now, and only for the next 2 weeks at the link on the screen or in the video description. It costs $500, which is a lot of money, but it's less than $3 per video we produce in a year. When you buy this, you make it possible for us to make SciShow for everybody else. And it will come in a package sealed with a very cool SciShow wax seal. And did I tell you that we are a nonprofit now, so it's also tax deductible? These X-ray diffraction pictures of crystals, called X-ray crystallographs, it turns out, weren't just good for learning about the nature of our universe, they also became an important tool for understanding chemical structures. Most famously, Rosalind Franklin managed the finicky work of creating a crystal of DNA and then shining X-rays through it to create this famous image. Once scientists learned how to read these patterns, they had a way to map the invisible architecture of atoms, from minerals to metals to complex molecules to eventually the molecule that encodes our genome, DNA. Science is a process, and we love to follow along with the developments here on SciShow. You'll see our list of references in the notes of every video because we like to keep up on peer-reviewed research. But that's a lot of work for a YouTube video, and we can only do it thanks to you. So if you can help us keep making hundreds of videos every year, check out the SciShow postcard and the spinner in the link in the description. Only available for the next 2 weeks. Still going.